On our retro board, we added support for the RGB-to-HDMI adapter. We first mapped the desired colors to 6-bit RGB space. We then used Logisim to diagram and test a circuit. After that, we breadboarded it to make sure it worked, then stuffed that logic into a PLD. Today we'll build a Verilog module based on that PLD code to add HDMI support to the retro FPGA. We need 8 I/O pins for this, so we'll need to reclaim those debug ports. And add the 12-pin connector. Connect up that module with a ribbon cable. Nice. Add that pin mapping to the PCF file. And add that to main. I'll start a new file for this section. For inputs, we'll need VSync, PSync, BSync, score, boundary, bricks, 16 Henry, and 8 Henry. We don't need HSync because we can simply assign it directly outside the module. She then puts out the 6-bit RGB data. Crap, let's just run HSync through here too so it's more consistent. And we need VSync. Coding is basically just a copy of the raw combinatorial logic we already did for the PLD. I'm creating separate wires for each RGB signal, easier to track. And finally assign those outputs. That should do it. Copy the signature to main and connect it up. All outputs drive main ports directly, so no need for any loose wires. We do need to get rid of that debug stuff. Oh, and also from the PCF file. And that old debug assign. Fix that. Looks good. Let's light it up. No smoke. Usually a good sign. Switch the monitor to HDMI input. Wow, I wasn't expecting that to work on the first pass. A really nice solution without having to do too much work, and you know we are lazy. I suppose we have enough room to implement cheap HDMI support on the FPGA. Driving a buffer is easy, but handling a plethora of monitors out the other side is best left to someone else. VGA support is possible, but if you remember it requires double the horizontal rate. It would be a good exercise for you to modify this for VGA. You can use all of the I/O we made today. Just run the RGB outputs through a resistor ladder. Well, great, finally a nice short one today without any loops. In the next video, we'll tackle the configuration, which will be interesting with only 4 I/O pins left. Think about how we can do that, and I'll see you over there.